So if sending humans to space is probably not very healthy, then perhaps we should send robots to space and pretend they're a bit like humans because they have AI installed on them. This is exactly what our last panel will look at. So how do we move from experiments on Earth to autonomous machines exploring space? Please welcome the moderator, Astrid Valtna-Dvořák from the Ministry of Economic Affairs and Communication. And she is joined by Helena Milevych from KP Labs and Dengel from Tartu Observatory. Now, unfortunately, Joosep Kivastik, who also should be in this panel, is actually currently stuck on a train that is not moving. So we have issues here on Earth with technology as well, not just in space. So the panel will have to do without him, but I'm sure you'll be just fine. Go ahead.
Well, warm regards to Joosep on his way, and we'll take his ideas on board for sure and share them with you. But with no further ado, let's get to the bottom of it. The race is on. Who will be the first commercial company who will manage to make just enough safe landing on the moon and bring back some meaningful data with them? Preferably, of course, this will be AI triaged, AI analyzed data that we can do something with. Wouldn't it be nice? And in this panel, from research to flight-ready autonomy, we will discuss what are the most pressing challenges in achieving technical autonomy and to excel on onboard payload processing. Where is the academic experimentation irreplaceable in this process? And how do we turn research prototypes into flight-ready systems? And finally, of course, we will look at how to succeed in product development and to make your space company sustainable in the long term. So please welcome our panelists, Helena and Rick. A few words to introduce them. I mean, Rick Dengel, you probably know very well already. And if you think of Rick, you think of Kuupkuulgur in Estonia. You think of several ESA projects, maybe most famous of them, the Comet Interceptor mission. But most of all, you're wondering if he's the guy who solved the puzzle on what should you do with the AI on board of your space mission, what should this AI do for you and what it shouldn't do for you, and will he be able to bring us the key how to be the one who wins the race? So we'll hear about it later on. Yes. And Helena is a long-term head of products for KP Labs, but today she's already affiliated with the Polish Space Professionals Association. She's also a jury at the European Rover Challenge, very interesting. And my personal favorite about Helena is how she actually describes herself. She builds and commercializes products from nothing to something that brings millions and makes a company viable. So big applause to our panelists, please. So, but let's get into this, and let's start from the beginning, from the academic end of it, and where it all begins. Rick, can you tell us more about Kuupkuulgur and knowledge transfer, and why is Kuupkuulgur actually such a special project?
So, for Kuup, we always call it Kuup. It's like our little child in the observatory. That's how we call it. As the
very good nickname.
Yeah. For us, it's like it originated from the idea we have a lot of different technologies, which we have in our different research institutes or with our partners together. And we're like, well, now we kind of want to try them out. And then we're like, yeah, we need some vehicle where we can put on autonomy, reconstruction, what can we do with our data, what can we do with the onboard processing. And we said, yeah, we need some vehicle which we need for that. And that's when Kuupkuulgur came to be. And over time, it developed into, yes, we're an observatory, we have a lot of students in there, so there's a strong educational component to it. And this kind of combination of PhD students and research and postdocs and those kind of things combined with students is very it's not unique in student teams, but it's not a common student teams. Like we may have it in the European Robot Challenge, their approach is very different on that. And it is what differentiates us from it. And of course, we also have the commercial aspect that we have other industry partners who use Coop in our analog facilities, and they're using the platform to develop their technologies. So that's a bit different than many other rovers, which focus on one thing, and we have multiple things. Of course, we want to go to the moon. That would be really, really cool. But it's not the only thing which we get out of it, and that's really rewarding, from a day-to-day basis to look at the students, what they're learning and how they're learning it.
Yeah, you're surely taking the most out of the process itself. You know, the project that lives on, the students come and they go. Does it also happen on the way that they spend some time with you, they learn a lot, and then they will go and they pivot, and maybe they will develop their own companies based on that knowledge they get from you?
It has not happened yet for the rover. But in the end, I mean, this is the best case scenario. There's people who work with Coop, they do their thesis with us, but they work with other companies. Various companies, I think also potentially also in the room here, but they learn the hands-on things. So in most of our students come from from the computer engineering degree in University of Tartu, and they learn their hands-on robotics thing like challenges, competitions, and after that they come then to us usually, or in the same time, and that's when they get into the product development or the software development from academic to industry part. And then they're ready for the industry, and then the industry benefits from this really hands-on and more mature way of developing things. So not quite into their own companies, but we definitely have people. I think the student rocket, we have this, of course, from S-Cube and from Coop, both people in there, and they get excited about doing more things, and that's a good thing.
Yeah, absolutely. I mean, it sounds very interesting. But Helena, would you validate it from your end of things, from your perspective?
Yeah, so I think there are few things that we could point out. First of all is that this kind of activities at the university is a great way to check whether it will work or not, what are the possibilities, what are the opportunities, but also to fail. I mean, this is exactly the place to fail. For the companies, in most of the cases, they try to avoid it by all means, because it's too risky, there are, everything at stake. So I would say this is a great way. Also, working with the spin-offs, with the groups, with the teams, however, they will be shaped in a formal or informal way. That's another opportunity for the companies to see, okay, what are in a safe, let's say in a safe space, in a safe environment, to see what could be done or not. So not to destroy the whole company, but to kind of, split this business into more stable one and more kind of disruptive, more risky, to see, okay, what could be done? And then based on the results, the company could basically merge or, buy the results of the research or kind of involve the whole team to the company. And that's the examples that we have in Poland, that there are some students' projects, some missions, PWSAT. PW is Politechnika Warszawska, which is Polytechnical University of Warsaw. And these are the group of the people who started a huge part of the Polish business in space, and they evolved into all the different companies. Yeah. So this is amazing thing, and this is a great example how you can start with the small thing at the university, check and struggle with the budget, where to get budget from, where to get knowledge from. If you're, I don't know, it's your first mission, right? Like, where do I start? What's the handbook? I need to read to understand how to, like in IKEA, you have this kind of manuals how to, screw everything and make sure that it works. So I would say that's another example. And also I will in some time we'll also speak about the ERC, the European Rebel Challenge, and it's another way how to connect the technology and the engineering process to the real value to the client, because that's the most important what we are doing. So starting from the university, it's a great way to understand, okay, I'm not bringing only the technology, the PCB or some, thermal management system or whatever, but what is actually driven is by the requirements from the space activity, from the space environment, from this specific spacecraft, from this specific orbit, etc., etc. So I would say it's another angle of these activities, how we make sure that, okay, it's not a technology, but it's something that has the value for the, for the one who will buy it in the future.
Yeah, absolutely. So in this context, it interests me if the experimentation grants also feed into this process at some point from company level or from university level, but more from a company level, I suppose.
Yes, I would say if we speak about the hardware, then definitely grants for the R&D is the most essential part where we should start. Of course, if we have investor, there's something different, but in different countries, it's not that possible, or not that many funds available, et cetera, So it is a great way to start the activity, to see whether it will work out or not, to do some kind of feasibility study, proof of concept. So there is some grant, maybe from the ministry, maybe through ESA, maybe some other national bodies that could support these R&D activities, maybe Ministry of Education. I think depending on the country, there is a long list of who could actually provide the grant, but also definitely we see that there are companies like Thales Alenia Space, like Airbus, some of the biggest companies, the LSI as we call it, large system integrators, who are looking for the young talents, who are looking for the technologies that they can adapt later on, and they will also pay some, vouchers, some cash to these companies to kind of develop this technology. So definitely there is a great way for this opportunity and for the collaboration also. So definitely all the contests that we have, we heard on the panel. I think that there will be the conference in the US where you could win some prize, right? So that's another thing that definitely could be very beneficial.
It's very, education definitely, and these student projects especially, they feed into the development of industry.
I was just about to say, it's very interesting, we, on Coupon, there's a very new project. It allows us to experiment a lot of things. And that is something which is actually interesting, of course, for companies as well. This is the space where we can try out things. And this applies for every student project in a sense. And the thing is, there's not only, maybe it's not the most mature technology, maybe it's not the best because it's like students learning it on the way. In my own experience, I think there's many people who have worked on student projects, sometimes they're not really reliable and they're kind of patched together or something. But the students, there comes technology out, but with the technology there come people who have developed creatively with experience that technology, and that is almost more worth than the technology itself, because if well supported in a company, that will be the actual good product which has been figured out from the very beginning. So that's something which is very powerful. Didn't quite think of that before, but yeah.
Yeah, I mean, this kind of learning, process is super important. That's for sure. But it's also great that we most of us, we're working in the new space, so-called. So these are the private companies versus so-called old space, which is the agencies. So that's definitely a space for the creative approach. How to make sure that what we do is actually applicable. How we can use the rules of IT, for example, the agile approach, all these methodologies, and we could apply this to the space-related activities, because also space is a very, let's say, big bag of everything. There's the satellites, the ground stations, the data that we are using, the applications. There is also all the different orbits and scientific and non-scientific. I mean, there is a huge thing, but definitely there are the similarities in different businesses that we could apply. So the same was for me. Before space, I was working in the IT industry, so this kind of product-oriented approach also was grounded into the IT industry. And it's also a great way, to learn and to transfer the skills from one area to another, which was also mentioned today a few times, that it could be either biology, physics, whatever you name it. But that's a great way, to adapt it and to, kind of coping mechanism in business. So if you cannot, achieve it right away, maybe there is some, a round way to make it happen.
So very good. So product-oriented mindset is is crucial for a knowledge transfer and successful space industry. Rick, tell us more about your current research and your current studies. Is it true what I said about you before? Will you crack the code?
It's a very complex question. Research is not always that easy. Not as straightforward. We try to always strive for very generalizable solutions. For some of the domains, that's the goal, definitely. To understand what I always say, like I study task complexity, device complexity, and figuring out what tasks can we do on what spacecraft, what mission size, what will it require. That is what I want to answer. I wouldn't say it's going to be a conclusive answer or cracking the code, but hopefully it's something where some companies or some future projects will know, okay, based on this work, we can make this and this decision, and then we have a more efficient, more capable, either or, right? Either it's more efficient, when it's more efficient you can do more things, or we will stay smaller. Those kind of things, hopefully that can enable it. And also that's definitely what I do in ESA Aztec with the onboard AI facility, which we have there for all the boards. We have like automatic pipeline to evaluate the boards. That's really what we want to do. And maybe it's not, maybe one of the results of my studies can be that there will be, maybe it's not generalizable, but then we have at least the tools to like test it per scenario. That doesn't have to be always all conclusive. It may be. I would be, of course, cracking the code would be very cool, but there's other steps. Again, I always like the path to things, and that path would also be very, very useful and very beneficial.
Very good. So if I translate it into my own words, so you're basically analyzing how strong of an AI model or AI algorithm you would need to use on board so that you would get the most out of it. Finally, like in the end, you have very precious few little days on your mission, and you have this precious little amount of energy with you. So you will have to be the person who says that to me, if I want to launch my mission, you will tell me that, okay, Astrid, now, if you want to get most out of it, take this amount of processing with this amount of energy, and then you will get the most optimal result. Is that?
That would be the ideal solution, and many people focus very much always on like the final step of like the chip. I need the most and latest technology, but we may talk about it in a bit. It's like not always is that the relevant part. It depends on the methodology which you use from the very beginning, and this is all very connected. That's one of the results of my research. And when I started my research, I was always like, yeah, I'm going to figure out which chip to use, and it will be like one thing. And over the years, you learn a lot of things, and then you say, yeah, it's a bit more complicated than that. Yes. But yes, you summarize very well.
Yeah, I like to make very complex things simple for my interface, you know. But tell me, last time we spoke with you also about training data and how it is crucial, etc. And like finally, you're training your model for going into the unknown, for visuals that you have never seen before. So what has changed within this 1 year that we spoke last about training data? Have you made any conclusions what to use? And honestly, like what can go wrong when you're training your model for something you don't know exactly what you're going to see?
I mean, it can see nothing. To answer that question very simply put, it can just go very wrong, and you have no good results. That's what we all try to avoid. It's a risk which we have, especially in like machine learning AI. That's always what we want to avoid. That's why we're going often very quite conservative. So what is quite common to do is actually, from my colleague like Joosep, they're working on terrestrial robotics, right? What they tend to do is like, yeah, we have the synthetic data, and we have trained everything on that, but the rollout doesn't happen in an instance. Like you start with just having something simple running, and then step by step, if you get more data and more data and more data, we say we don't have any data. How do we solve the problem? We go first there without needing the data, and then we can gather the data to enable later. It has also to do with technology maturity and those kind of things, but you try to combine, and what you can do very well with synthetic data is assess complexities, like what I'm trying to do. You can very well define a task and study it very well because you have control over that data. And that may, in many cases, and that's what we want to get to, of course, to actually also use that same model with the same data trained in reality. But we also have to be realistic in reality, in real life, to actually like see that it may not be the case, and we need to adapt afterwards to that. So that's the realization which we more and more have. There's a big gap. There's various approaches to handle them, but in the end, it will always require some slow rollout. And I think Helena can add some things on the slow rollout part.
Yeah. So I have this intriguing question. I'm sorry that Joosep is not here, because Joosep is training automated vision on terrestrial data. And what intrigues me is that if Joosep would be able to train his model and to bring a full autonomy, would you consider using his training data also for your mission? Like his terrestrial training data?
Well, if you find a planet where there's life on it, like trees and everything, yes. But rather not the data, the tools which are being used to create that data. I think that's the essence in itself. We know that the terrestrial off-road kind of things, they behave very differently than our like driving autonomy of cars.
Yes.
That's what we know is very different. And we know there's the lunar environment, for example, or also the Martian environment is closer to the off-road, and that's kind of logical, than our human structured environment. So it is a step towards that, and the lessons we learn in this terrestrial application domain, that is definitely useful for the off-road lunar environment in that sense.
Yeah, the rovers, they are very intriguing. And last year you had your Kubkulkur here as well. What an amazing bit of technology it can do. It can go to places. It can crawl over very many things.
Including humans.
And maybe if we think of rovers, but let's focus on Helena, you right now. Please tell us more about the ERC challenge and what has this experience brought to you, and has this enabled you to see also some angles or problems that from company's perspective you didn't see before?
Yeah, absolutely. Just before this, I will also want to add on what Rick mentioned. There is a nice word in the space industry, trade-off. So we want to trade off everything depending on how much energy we have, depending on the architecture, the orbit, this and that, etc. We try to balance and make sure that the system is sustainable. This is one thing. And another thing is that's what Rick also mentioned, that there is no universal solution to everything. So depending on the Earth observation mission, or it could be in-orbit servicing, or it could be some, rendezvous or something else, we might need a bit different tool, a bit different architecture, because some of the chips, they're better suited for the visual data, some of them are for the radars. So I would say this is a very flexible thing in some extent. So it's kind of product, but we still have some level of so-called delta development that we have to do to make sure that it does fit the purpose. And that's the the thing that we have to make a decision based on all the different factors. But getting back to the ARC, the European Rover Challenge, this is the biggest one in our part of the world. It's based in Poland, currently in Krakow, so I really would like to invite you to come and see. It's normally end of August or at the very beginning of September. And you have direct flights from here to Krakow. That's how I came. So the idea is that we have, like last edition this year, we had over 100 applications. Yes, and only 25, I guess, got to the finals. Okay. So it's a serious stuff. But what I was amazed is the creativity of the students. It's not about the budget. Sometimes budget is just a tiny piece of the whole process, and that would amaze me. That it's like in the real space environment that you always have risk. You always have this something that can disturb the system. So 5 minutes ago, your rover is working perfectly, drives here and there, autonomously, no issues at all. And then 5 minutes later, you put it to the yard, to the Mars yard, and it's like, it doesn't want to work. Even if it's a huge budget, with all the sponsors, and it's not your first time up there. It's just, there's always this element that you are not sure if it will work or not until the very last moment, and you have to repeat this thing in a different task, like whether it's navigation or it's autonomy navigation or some drone tasks or checking here and there, like maintenance tasks. So that's an amazing thing, that it could be the best budget, and still it will not be enough, that you still have to have this a bit of luck. And I think there is the parallel, the bridge between the first moon landing, as we see, all the kind of podcasts and reports, and this team was also describing that they were not sure if they land, whether they will get back or not, because that was for the first time. I mean, there is no guarantee. So this is also very, very similar to what we have in the companies, in the space environment, that you could do everything perfectly, but then your satellite just do not work, and you can do nothing with it. I mean, in the car, you can go and repair the car. You could call, someone will come, the mechanics, they will, make sure that the car goes on. But in space, it's not like this. Like, once it's up there, you can do nothing. Of course, you can restart, reboot, do this and that, some changes in the code. But if something is wrong with the hardware, then sorry, not sorry, it won't work.
Yeah, it's very harsh. It's very harsh.
Yes, and also like this creativeness, this is another issue that I saw during the ERC, like how people, like teams from India, for example, or from other, let's say, more remote locations than from Europe, how they come, what they have to count, to calculate due to all the regulations, like you have to follow the regulation with the batteries, you have to make sure that you will be able to get the battery at the final location or something differently, or if it's waterproof or not really. Like you have to use something that you just can buy at the mall, at the shop, to make sure that you could waterproof. So yeah, that's very interesting to see, and also this is very. The very skill that we want to have at work, at the company, that you have to have this creative mind to make sure that you could resolve the issues that you were not thinking yesterday. Because it's very, especially now when the geopolitical tensions is happening, so we are not able to buy, for example, some components, so we need to do something to have them still on time, but with a new provider. So it's this creativeness and this approach in a different way, how you could mix it. That's a great thing. And the last thing I would also mention, the team spirit. How, like this year, I saw how one of the team from Germany was helping another team from Germany, and it was like amazing. Like they are the competitors, but they still had this will to help them to make sure that they are presenting their best. So that was also great vibe, great spirit, and yeah, I think I was positively shocked, and I think that's the way how you still behave in a good manner towards your competitors.
It's impressive. Yeah, it's very impressive. But I can imagine only that the whole challenge is also under very huge magnifying glass from the industry side, that they're very curious what the students are putting together, and they manage to deliver. Mm-hmm. What does the industry say?
Yes, and actually some people who are not a first-year comers, they come and say, thank you so much, thank you, because of the competition, I learned this and that, and we were talking to the sponsors, and I found my first job in the space industry. So they're not a white page, they already have the experience, because they have to use exactly the same, like there are teams who are like 10 people, 15 people, but there are also teams who are 60 people. So you have to manage 60 people. It's kind of not that small company, right? So you have to use the proper tools for the management. You have to do all the work related to the documentation, how to transfer the knowledge, how to teach new people, how to enroll new people, how to do the budget, all this stuff, how to do the marketing, because there are also points for the marketing, like to do all this stuff that is necessary. And you could actually, this is a hands-on experience on what this work looks like. So it's not the pure engineering concepts, because there are a lot of engineers who they love to engineer. I mean, it's not bad. I mean, they just love to engineer. To some extent, they're nerds. They love this thing, and this is great. But on the company perspective, you have to always think about, okay, I do this technology because I want to do the technology, or because I want to solve a problem. So if we solve a problem, that's a completely different thing. So this IRC is also helping to think in this way. So there's the requirements, that you have to follow the requirements. You know what you're getting points for. So there is also kind of the mindset that I'm not doing to do, but I'm doing to fulfill the specific requirements that will bring me, some additional points. Or, for example, the other way around, one team knew that they're not great in the autonomous navigation, that we had, additional points for. So they said, okay, we're not doing the autonomous navigation, but they did perfectly the navigation task itself. So kind of, it's also about the realization, what are my strong points, where I could, hit and get the best out of it, and what is better, I just, limit my involvement in, because I know that I won't make, I cannot cover everything. And it's exactly like it works in the business. I cannot cover everything. So we need to cover the specific parts that we are good at. We call it unique selling points. So we want, as a company, want to invest in this unique selling point, and then to leave everything like, okay, one day we will get there or not.
Thank you, Helena. I think this is very precious input what you just said, and I hope you guys made some notes.
Yeah.
Because I think this secret actually was open to us right now, how to make your own space company sustainable and viable. Surely, because when you're about to start, you might, after your student project, perhaps you might get your own first project involvement in a bigger mission. But then what?
Yeah, I would say it's a combination of, various factors. It could, if we are at the beginning that know exactly what we are good at, it's a good thing. I mean, this is the process, right? You're learning during the way, and then you will find out. But before you find out, it's good to try different things, understand what you're good at, and then kind of narrow down your activities. So make a pivot, from the broader perspective to a narrow perspective, to be good in this specific narrow perspective, to be sustainable in this, and then to think, okay, I am now sustainable in this, and I have enough capabilities to, hit another another direction or similar direction or something complementary. So this is kind of to feel where the moment where the company in or the team at, to understand what strategy is best at this specific moment, and it's could make the best out of the situation.
Absolutely. So if I narrow it down again, simplify it for myself, then first you aim at solving a problem, and then you become really good at it. You choose your avenue, and you beat everybody else in it. So, in the big evil business world, if so to speak, so how would you prioritize? Like when is it good to get involved in a let's say nationally funded project or ESA projects, or when is it good to go just straightforward, like on your own commercial? Is there any guidelines there?
So I would say if we require some R&D funds, then absolutely ESA is a great thing. There is the GSTP program, there are other programs, then national funds, absolutely. We just need to make sure that it is aligned to what we want to do. So this is one thing. And then as soon as we have it, if there is no investor at this specific point, so we have this, we test it, we do some proof of concept, and then we could also move a bit forward. It might be the investor, but it also might be a combination of projects and products, which is also works pretty good. So I would say, again, depending if it's software, if it's algorithms, if it's hardware, there are also companies who do specifically scientific stuff, and they're happy with it. But you have to be aware of what you want to do, what is the final goal, and adjust all these tools, all these funding opportunities to the final goal. If it's a defense stuff, it's very different. Like if it's a defense stuff, normally you're not involving the investors, the private investors. The main investor is the government, and that they want to do it a very specific way. They want to, have the least public appearance as possible. So it's very different. So I would say, depending on the final goal, we need to adjust it. But ESA, it's a great way to cooperate, and it's a great way to learn the whole ecosystem, like what exactly is happening up there, what are the trends. Because also, if you go and check, ESA has the very specific roadmaps, the plans that, okay, for the next, we are having ministerial very soon. So we also, we know what countries will invest in which specific programs, in which areas. So it's also kind of direction for us for the next 3 years. Okay, so I want to do this, this, and that, or my country supports this specific program. So it's also, I think in Estonia it's a bit easier. In Poland, we have a bit more companies, and they're going all into the different directions because the country is a bit bigger. But that's another way. And then you could also shape yourself, to make sure that the right partners will find you. Not only you will find the right partners, but also they are aware of what you're doing. And I would say ESA is a great stuff for this kind of cooperation.
Yeah, so ESA builds the network wider, deeper as well, and allows probably companies with very different profiles to enter the market.
Yes, and just one last thing. ESA also is kind of a must that the LSI, large system integrator like OHB, like Thales, Helena Space, and Airbus, they have to cooperate with the SMEs, with small and medium enterprises. So it's a must. So it is very much into this cooperation. So they also have different calls for, in between different countries. So it's another way how you will have to cooperate. There is no other chance. So it's also the mechanism of ESA that forces you to be enrolled into these international activities.
Very beneficial. Rick, would you like to add anything from your perspective?
I can just agree. It's more and more ESA finds its role of being someone who brings more collaboration together. Of course, in a new space, I try to adopt in that direction, and we see that really happening in a sense of there's a lot of things to do, a lot of things to improve, but what we can see is that more and more they try to bring the different capabilities and the things which companies are really good at, those different things together. There's the big companies which kind of do everything, but as a smaller company, it becomes, I don't want to say easier, but it's more facilitated to become good at one thing, and then you will be known for this, and you will get your opportunities to provide the thing you're really good at. And that's a very good thing, and without something like ESA, we would have to do everything at once, and then I can't be doing everything very good. And Europe is like a region which really focuses usually on excellence, on making things very good. There's very, very many very specialized companies from trying to make mirrors for chip production and all these kind of things. And that's something which I think Europe should continue to do, and is really can make it very strong, because that's where our high-tech things come from. And that's, I think, a good way to continue having the best technology which we can possibly have by enabling the companies to focus on one technology or area or something like this, and not having to do everything, because I know there's other people who do other things, so I can do what I want to do, and someone else will provide me reliably the best thing of their domain.
Thank you. I mean, it's a very good overview of how ESA actually can support the ecosystem to evolve. So, how about our audience and people online? Is there any questions that have landed from behind the screens? Anybody from the hall would like to ask questions from Helena and Rick? Silence.
It's late in the conference.
Okay.
Yeah.
So
Well, it means either everything was so clear or everything was so unclear that people don't want to ask.
I think people are already like quietly like making the sketch in their heads. Okay, so how I will strategize my project? You know, I will get involved in that high-profile project, but meanwhile I will develop my capacities further and further. And you know, based on this experience, I will start developing side capacities coming from other areas, so that I could broaden my portfolio. I think, like, at least if I was in the audience, I would be already like, you know, drafting my little.
We have a question.
Plan.
Finally.
Wow!
Very
Please.
excited.
Yeah.
Thank you. It's a good question. Thank you, Paul.
Are you a psychologist? Just, you know, a question. Answer question by question. Are you a psychologist? Is this some study?
It's a very explorative. Yes.
I will be a rover. Yeah. Rover, or maybe even helicopter. You know, that's I really fascinated by the helicopter that was sent by NASA. It was supposed to do like 5 flights and that's it. And apparently it ended up with over 50 of them destroyed by an accident. So yeah, I will be that little helicopter that surprised everybody with its journey.
Yeah, and it is very good at landing.
Yes, exactly, and overseeing, you know, like we have this helicopter, you know, view. So yeah,
Yeah. Small but powerful.
exactly.
Rick, what about you?
You're talking about the rover. I mean, of course, I think it's kind of clear what kind of technology roughly it will be for me, but I think for me it would be like the technology which enables the helicopter to find its way, like perceive and figure out what do we see. And I always like to say one of the things which really inspire me, and I think I said it last time actually as well, is that we don't know how to figure or how to detect what we have not yet, have no idea how it will look. Like we look for anything unknown, if it's live, new chemical compositions whatsoever. Autonomously, we do not know how to classify that because it will not go into any of our classes which we know so far. So how do we find that? And that kind of technology, that's what I would like to be, because that's like always this kind of finding its way and seeing the newest things and like being inspired by that. That would be very cool.
So overview and exploration is what the team of the two of you would put on the table. I would come by as an assistant. I would be R2D2 for you guys, for sure.
Great.
Yes. I hope we answered exhaustively to the question, Paul. Yeah. But if there are...
What's our psychological profile? Okay. Did we pass the test? You know, that's the question with our profiles and answers.
We will be guided down the alley of scientific geniuses as we exit this room. It's to the right. Yes.
Great.
But Helena and Rick, thank you so much for this very interesting and very deep conversation. I think I at least got an idea what I would have to do if I were to enter the space industry. And definitely maybe one day I will consider it.
Definitely.
But thank you so much, and always welcome back to Tallinn.
Thank you. Thank you so much for
Big round
inviting.
Thank you. Big round of applause for our panelists.
Indeed. Thank you so much, guys. C3PO enters the stage.